Hi, I'm an old guy and I do maths. Today we're going to look at the different types of triangles that you can come across. They divide up into three basic types. And we'll start with the one that's probably got, it's got no real variations except in size. And that's an equilateral triangle. Now, an equilateral triangle is distinguished by having each of its sides being the same length, and that has a consequence. What it means is that this angle, and this angle are all the same. So, an equilateral triangle has angles that are all the same and sides that are all the same. Now, the sides can vary in length as long as they are all the same length. So these could be 2 centimeters long, 20 centimeters long. As long as they are all that length, the triangle will look like this. And if they are all the same length, that means that these angles are all the same. And as the angles on the inside of a triangle add up to 180 degrees, and these angles are all the same, it means that each of these angles is 60 degrees, which is a very, very handy thing to know. So that is an equilateral triangle. There is not a great deal more to say about it. The next triangle that we should talk about is an isosceles triangle, which is one of these things. Now I've drawn one with a 90-degree angle in here, and I've drawn one with without a 90-degree angle. The thing that distinguishes an isosceles triangle from anything else in the triangle world is that two of its sides are the same length. So we've gone from 3 sides being the same length up here to 2 sides being the same length. And because 2 of the sides are the same length, 2 of the angles are the same. Those angles in this case are down here. So if you happen to know what this angle is, it's easy enough to work out these two. Now we know this angle in this case is 90 degrees. We know that the angles on the inside of a triangle must add up to 180 degrees. So that leaves us 90 degrees that we have to split evenly between these 2 points, these two points here, these 2 angles here. So this is 45 and this is 45 degrees. So where you have a right-angled isosceles triangle, the other 2 angles on the inside of it are 45 degrees each. And the qualification for an isosceles triangle is that 2 of the sides should be the same length. Now here we have something that looks different but is still an isosceles triangle. And let us say, for example, that this angle up here is, what does that look like? Let's say that it's 40 degrees. That's probably a little light, but that will do. Now if that's 40 degrees, these 2 other angles, being the same, must add up to the difference between 40 degrees and 180 degrees. So that's 180 minus 40, which gives us 140 degrees. Split that in 2 and you get 70 degrees here and 70 degrees here. That is what distinguishes isosceles triangles from equilateral triangles. Again, equilateral have 3 sides the same, 3 angles the same. Isosceles, 2 sides the same, 2 angles the same. Right, let's move on. So if we move down the page to scalene triangles, now I need to put that symbol in there. Now, it should be fairly obvious when you look at this what a scalene triangle is. Well, it's neither of the other 2. It's distinguished by having sides that are all different lengths. Now here's a right-angled example. The best that we can say is that if we know this angle, which is 90 degrees, these other two sides, when combined, will add up to 90 degrees. But there's nothing based on the information that we have here that allows us to figure out without measuring what this angle is and what this angle is. All we can say is that the other two in this case add up to 90 because that is 90 degrees. And that's because all the sides are different, so all the angles are different. Now there's a theme here. If we think back to the equilateral triangle, all the sides were the same, therefore all the angles were the same. The isosceles triangle, two of the sides were the same, so therefore two of the angles were the same. None of the sides here are the same, so therefore none of the angles are the same. And we have even less information to go on here, because there's no right angle in here to tell us that at least we know one angle. All we can say, again without measuring, because we have no other information, all we can say is that this angle plus this angle plus this angle add up to 180 degrees, which is the common feature of a triangle. All the angles on the inside of a triangle add up to 180 degrees. That's a very useful thing to remember. Okay, so that's a basic rundown of the three types of triangles and their qualities and the information that you can work out just from knowing what they are. I hope this is helpful. It's designed to be a basic grounding in triangles. Thanks very much for watching. See you next time.